Today I'll be solving a scenario that is an example of inelastic collision. A bullet is fired at a wall that is attached to a spring. The bullet is embedded into the wall and causes the wall to move 15 centimeters from its original point. We are given the mass of the bullet, which is 8 grams or 0.008 kilograms. We are also given the mass of the wall, which is 0.998 kilograms, as well as the force needed to move the spring 0.25 centimeters, which is 0.75 newtons. First off, we need to convert the centimeters to meters, which is 0.25 centimeters to 0.0025 meters. Okay, then we plug into the spring force constant equation, which is K equals absolute value of F and absolute value of X, where F is the 0.75 newtons and the X is 0.0025, which would give us a 300 newtons per meter as the constant. We then plug it into the equation of the conservation of energy, which is K1 equals 1/2 velocity times displacement squared. We then rewrite the equation to find velocity, which would end up being V equals X square root of K divided by mass total. We plug in the values, which would be 0.15 meters square root of 300 divided by 1 kilogram. 1 kilogram being that it's from the mass of the bullet, which is 0.008 kilograms plus 0.998 kilograms, the mass of the wall, which would give you 1 kilogram. You should then get the value for velocity, which would be 2.6 meters per second as your final velocity of the wall. Now, to solve for part B, which is finding the velocity of the bullet, we have to use the conservation of momentum, which is mv initial equals mv final. So the velocity initial equals to mv final divided by the mass of the bullet, because it's the initial velocity that we're solving for. Then you set it equal to the equation. This is the mass total, and this would be the final velocity, which we already solved in the previous equation, which is 2.6 meters per second. So plugging those in, 1 times 2.6 meters per second divided by the mass of the bullet, which is 0.008 kilograms, you end up getting 325 meters per second for velocity initial, and that's how you solve the equation.